Test lights are classic diagnostic tools, but even veterans get tripped up by unsafe or misleading techniques. In this lesson, you'll see how to use a test light with confidence, knowing when, where, and how to test without damaging components or drawing the wrong conclusion. Before connecting a test light, understand the complete circuit: power, load, ground. A test light glows when current flows, confirming a full path, but it can't detect high resistance or show which side, power or ground, is missing. Knowing the circuit layout prevents misinterpretation. A test light can reveal problems a meter misses, like circuits that read 12 volts unladen but fail under load. When a test light doesn't glow, there's an open or weak ground, not just missing power. But a meter's high impedance reading can't always catch poor connections. Each tool answers a different diagnostic question. To verify power, connect the test light clamp to ground and probe the suspected power wire. The bulb should light bright if power is present and the path can carry current. For ground checks, connect to battery positive and probe the ground side. Dim or no light means an open, high resistance, or missing path. Always confirm tool connection and circuit capacity before judging the result. If the circuit has an open or a direct short to ground, your test light makes it obvious, but internal faults, like corrosion, can limit current while still faintly lighting the bulb, fooling you into thinking the circuit is good. Similarly, if a high resistance path is present, the test light may still glow, but the real load won't work. When diagnosing, always move along the circuit, from power supply to load to ground, proving each leg can carry current before moving on. Combine test light and meter as needed, and confirm results before condemning a component. This saves time, avoids unnecessary replacement, and keeps sensitive modules safe. Never use a test light on computer data lines or low-voltage reference circuits. One probe can damage modules. And don't assume a single clue confirms a part is bad. Always confirm circuit capability, check scan data or symptoms, and perform additional tests before replacing any component. Use this step to name the condition, the observed data, and the confirmation path that separates this scene from the rest of the workflow. This scene narrows the decision to one specific measurement or clue, then points to the next action that confirms or rejects the suspected fault. The visual evidence in this scene should explain why this test comes now, what result matters, and what mistake it prevents. Use a test light to prove, not guess, never on data or reference circuits. Always confirm each segment of the circuit, and combine tools and logic for the most accurate diagnosis. This wraps up your guide to using a test light safely in diagnostics. Apply these best practices to every test for safe, confident, and efficient troubleshooting.